Hi all, I am Ratnakaram Raju from the CompetitIve.in, the only one platform at your service to enhance your skills. In this video, I need to discuss about the atoms and periodic table. Next, go to the other slide. John Dalton's atomic theory. First, all of us need to know what is a atom. A atom is a tiny molecule or a particle in which all the matter around us are made up of. John Dalton's atomic theory postulates are all matter is made of atoms. Atoms are indivisible and indestructible. All atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms. A chemical reaction is a rearrangement of atoms. Then goes to another slide. As we know, we have many subatomic particles like electrons, protons and neutrons. Electrons are, for example, let us take a circle in which the nucleus is present at the center, in which the nucleus, all the protons are and neutrons present in the nucleus. The expect space between the circle and the nucleus is called as the extranuclear region where all the electrons are present. The protons are discovered by Rutherford and neutrons are discovered in 1932 by Chadwick and electrons are discovered by J.J. Thomson. These are the direct theoretical questions which are asked in many competitive exams. Please note it again. Protons are discovered by E. Rutherford in 1919. Neutrons are discovered by J. Chadwick 1932. Electrons are discovered by J.J. Thomson in the year 1897. Okay, next go to another slide. Atomic particles. As we know, for everything we have properties. Like that, for the atom also we have some properties like atomic structure, atomic number, isotopes, isobars, atomic mass, and others various kindly difference on the atoms. For example, let us take atomic structure. There are 115 known kinds of atoms, one kind for each element, and all protons and neutrons extranuclear region containing all electrons. Atomic number. The number of protons in the nucleus identifies the atom and equals the atomic number. Mass number is also same to that protons, neutrons also. Isotopes, atomic mass, variation of atomic structure. Isotopes. The atoms of various isotopes are being classified as the number of the protons or neutrons which are present in the nucleus are to be considered here. Atomic mass. The average mass of all isotopes, which I said earlier, of an element weighted according to a natural abundance to the atomic mass here itself. These are some of the atomic properties while we discuss. Next, go to another slide. Atomic theories in history. As earlier we discussed Dalton atomic theory, like that we have Thomson's, Rutherford's, Bohr's, quantum mechanical, Heisenberg, Skondel, Planck, Einstein, etc. Next one, another slide. Atomic weight. Atomic weight. Sorry. Atomic weight is one of the important topic in atomic structure and atomic properties. Weighted by percentage average of the mass of the naturally occurring isotopes of a particular element. Next, go on the slide. Electron arrangement, the quantum mechanical model of the atom. The amount of energy each electron has allows it to occupy a defined spatial region at a certain distance from the nucleus itself. And the further from the nucleus, the greater the number of electrons that can share the space even. Electrons move about the nucleus, therefore have an kinetic energy. As we know, as the electrons, some of the electrons all around the turning around the nucleus, but some of the electrons are trying to be in the nucleus. So they must possess the kinetic energy to be in the nucleus itself. Next, go to another slide. Orbital shapes and subshells. We have 4 types of orbital shapes: s orbital, p orbital, d orbital, and f orbital. And s orbital has spherical shape, p orbital has 2 loops, d has 4 loops, and f orbital has 8 loops, where the s can p can 2 and d can 4 and f can 8 loops. Next one on the slide. Configuration order. The chart here which is shown in the figure is called as the Euler's chart, where we need to be considered while writing the configuration for the element. Okay, order. The order of filling various electron subshells with electrons following the same order given by the arrows in this diagram. As I said earlier, this is the Euler's chart where to be considered for the configuration of any element. First, we need to write with 1s, 2s, 2p, 3s, 3p, 4s, and next to 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7d, 7p. Next, go to another slide. Electron configuration. The order of filling various electron subshells of different overlaps. This overlap is due to the relative energies particular shaped region of space. Let us take here 5 filling order 5p, 4d, 5s. Let it be 4, 4p, 3d, 4s, and 3 of 3d, 3p, 3s, 2 of 2p, 2s, 1 of 1s. Let it be from down to up. Then we have a chance to understand. Okay. First, we need to write with 1s, 2s, 2p, 3s, 3p, 3d, and then 4s, 4p, 4d, 5s, 5p. This is the filling order where the 3d, 4s, and 4d, 5s are shell overlapping. It is not at a mandatory, but we will discuss it later. Next, go on the slide. Examples. For example, we have in various elements, right? For example, as I shown here, oxygen, sodium, calcium, iron, and cadmium, bromine, zinc, lead. For this, let us try to write the configuration and let it be presented in the chart box. I will see the answer. If there is any mistakes, I will let it be considered in the next video. Next, go on the slide. Abundance of elements. As we know, we have many elements. For example, abundance of elements in the universe and the earth crust. Universe, hydrogen is of 91%, helium 9%, and all others are of less than 0.1%. Earth crust, oxygen 60.1%, silicon 20.1%, aluminum 6.1, hydrogen 2.9, calcium 2.6, magnesium 2.4, iron 2.2, sodium of Na symbol 2.1, and all others which are to be considered 1.5%. Next, go to another slide. Elements in the body, human body itself. Water, carbohydrate, fat, protein. Element composition of the human body which is shown here. Hydrogen, oxygen, carbon, nitrogen. Okay, next go to another slide. The known elements. We have a 115 elements, but we have known here. Let us discuss first 30 elements like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, copper, zinc, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These are the first 30 elements of the periodic table as we know, and these are the very important. Okay, next go to on the slide. Modern periodic table. In the modern periodic table, we have 7 periods and 18 groups. The 18th group is called as the noble gas group and the 17th group is called as the halogen group. The 18th group elements are helium, neon, argon, krypton, xenon, radon. These are the noble gases. We have 7 periods, right? 1, 2, 3, 4, 5, 6, 7, and the 18 groups are shown here as of numbers and of Roman numbers too. We have radioactive elements too. What are the radioactive elements which are hazardous to human health? But by the radioactive elements we can produce more than a power by through anything. For example, let us take a thermal power plant. It can generate 100 kilowatt power. For example, if you place or construct a plant of uranium, then we may have a chance to product 150 or above 150, and it be the 500 kilowatt power. So it is the power of uranium. Some of the radioactive elements are uranium, thorium, plutonium, radium, and some of the things. Okay, next go to another slide. Metals when non-metals on periodic table comparison. The light green color which is shown in the here are called non-metals, and the gray is shown in the figure is called as the metals. Some of the non-metals are oxygen, chlorine, beryllium, bromine, radon, xenon, krypton, and some of the metals are zinc, cadmium, lead, aluminium, something. Okay, let's go to another slide. Periodic trends of properties, atomic size and ionization energy. These two are the main thing in which many of the Olympiad are to be focused on these topics. They may ask the direct questions based on this atomic size and ionization. Based on atomic radius, in group atomic size increases, but in a period row decreases. Ionization energy means energy needed to remove an electron from a neutral atom. As I said earlier, all the electrons are revolving around the nucleus, but some of the electrons has to be pretend to be in the nucleus. But we have to possess some energy to make that electrons from out of that. So that is called the ionization energy. That ionization energy in the group or column decreases, but in the period or row increases. Let's go to another slide. Review. This is the review about this video. Atomic structure: nucleus contains protons, neutrons, electrons surround the nucleus, atoms have protons, nuclear symbols, isotopes, atoms of weight, element, atomic weight calculations, electron configurations, periodicity and periodic table, configuration information. And this is all about the atomic and periodic table, atomic structure and periodic table. And let us have some topics here which are to be discussed in the next video. Thank you.